We were looking at distributions and we were looking at our diamonds data set. Let's take a look at another interesting view of the same diamonds data set using a bin width of 0.01, a very small bin width. There are some interesting questions that this type of distribution raises. Why are there more diamonds at the whole carats and common fractions of carats, right? So you see one as a whole, one, 1.5, 1.25, and then less as you go small when you get away from it. Why are there more diamonds slightly to the right of each peak than there are slightly to the left of each peak? So you notice when you get the whole diamonds, there's not much to the left of it, but you do have a lot to the right of it, and that's across the board. And lastly, why are there no diamonds bigger than 3 carats? You see, there's nothing bigger than 3 carats. In general, clusters of similar values suggest that subgroups exist in the data. To understand the subgroups, ask yourself, how are the observations within each cluster similar to each other? How are the observations in separate clusters different from each other? How can you explain or describe the clusters? Why might the appearance of clusters be misleading? Let's take another look at a histogram of data from Old Faithful. So if we punch in the code, data equals faithful, mapping equals AES, X equals eruptions, and geome histogram with a bin width H equals 0.25. ggplot data equals faithful, and we've got a comma. And so you see, this brings up an interesting distribution also. Many of the questions that we ask will prompt you to explore a relationship between variables. For example, to see if the values of one variable can explain the behavior of another variable. We'll get into that shortly. But this is another unusual distribution. Let's take a look at the diamonds data set. So to look at unusual values. So we're jumping between data sets, but that's just to show you when you have multiple groupings that should explain something about the data. Outliers are observations that are unusual, data points that don't seem to fit the pattern. Sometimes outliers are data entry errors. Other times outliers suggest important new science. When you have a lot of data, outliers are sometimes difficult to see in a histogram. For example, let's take a look at the diamonds distribution again, and we'll keep the bin width at 0.5. And we're going to be looking at just the count of Ys. So you see, what's interesting is everything's clustered between 0 and less than 10. However, the graph on the y-axis goes all the way to 60. There are so many observations in common bins that's rare that bins are so short that you can't see them all. To make it easy to see the unusual values, we need to zoom into the small values of the y-axis with chord Cartesian. So you can add to your same code, you can add the chord Cartesian function. And here you can see there are some weird outliers. We've zoomed in. So the xlim argument is used to zoom in to this location. So you can see we punched in 0 to 50. So the max of the y limiter is going to be about 50. So it's a little bit more than 50. but it goes a little bit below and a little bit above 50. This allows us to see there are 3 unusual values: 0, 30, and 60. The y variable measures one of the 3 dimensions of these diamonds in millimeters. We know that diamonds can't have a width of 0 millimeters, so these values must be incorrect. We might also suspect that measurements of 32 and 59, 32 millimeters and 59 millimeters, are implausible. Those diamonds are over an inch long, but don't cost hundreds of thousands of dollars. That's not a reasonable assumption, right? It's good practice to repeat your analysis with and without the outliers. If they have minimal effect on the results, you can't figure out why they're there. It's reasonable to replace them with missing values and move on. However, if they have a substantial effect on your results, you shouldn't drop them without justification. You'll need to figure out what caused them. Was it data entry? And disclose that you removed them when you write up your findings. In the next video, we are going to tackle missing values and do some covariation exercises.